Hello, my dear friends, students, and learners. This is Sir Palmath, and welcome to my video channel. In this video, we are talking about the introduction to factorials and fundamental operations which involves factorials. So let us begin with our learning objectives for today's topic. So hereby our learning objectives. First, you will be going to understand the brief and concise concept about factorials in terms of etymology, origin, their use and application in real life. Next is, you will be going to apply the factorial notation in order to us to simplify mathematical expressions containing factorials. And lastly, you will be going to perform fundamental operations which involves factorials. So my dear friends, students, and learners, are you ready to listen for this today's topic? So let's start. To fully understand first about the basic concepts on factorials, let us begin with their etymology. The word factorial comes from the French word factorial, and it was first used in the year 1800 by Louis François Antoine Arbogast, and this is the French pronunciation of his name. In his work on Fa de Bruno formula, but referring to a more general concept of products of arithmetic progressions. So Louis François Antoine Arbogast, he introduced the word factorial and comes from the word in French which is factorial. So factorial, it sounds like factorial. So Fa de Bruno's formula, it is the first work made by Arbogast. So let us proceed to another one. The word factors, that this name refers to these terms of the product formula for factorial. So from the word factorial comes from the root word in English which is factor. And this refers to all the terms of the product formula which is known as the factorial notation. So my dear friends, students, and viewers, so let us discuss about the definition which is the factorial notation. Mathematicians use an exclamation mark to indicate the product of the natural integers is less than or equal to n. So mathematicians, we use the symbol exclamation mark. So this symbol is different from in the subject mathematics and language. So in language, we use this symbol to express your excitement and exaggeration, while in subject mathematics, we use an exclamation mark to indicate the product of all natural integers which is less than or equal to n. So in general, if the value of n, where n is a natural number, is a positive integer, then n factorial denoted by n and exclamation mark. So which is expressed as the product of all integers which is less than or equal to the value of n. So in short, the factorial function of a positive integer n is defined by the product. So we can read as n factorial is equal to n multiplied by the quantity of n minus 1 times the quantity of n minus 2 times until you reaches to 3 times 2 times 1. So that is the formula for factorial notation, where the value of n is any natural number or known as the counting numbers. So counting numbers that we use from 0, 1, 2, 3, and of course until any positive whole numbers. So my dear friends, students, and viewers, so here is the question. Who introduced this notation for factorial? The notation n factorial for factorials was introduced by the French mathematician Christian Kramp in the year 1808. And many other notations have also been used. So the French mathematician who introduced this notation was Christian Kramp in the year 1808. So factorial notations and its application. So what are those uses and importance in, or we could be applied in real life situation using factorial notation? The earliest uses of factorial notation which involves counting permutations. So when we say permutations, these are the number of arrangements that could be, or number of different ways that arrange the number of distinct objects into a sequence in a row. Okay? So factorials appear more broadly in many formulas in combinatorics. So when we say combinatorics is a branch of mathematics which deals with the arrangement, the number of possible ways in their arrangement. It could be in any specific order, or which the order is important or not important. So depending of their types of arrangement of objects. Okay, so my dear viewers, my dear learners and students, so here are some of their factorial values starting from 0 to 10. So let us start with the factorial of 0, and this is known as their special case. So special case, there are many of their conjectures and counterexamples which is related to factorial of 0. The factorial of 0, which is known as the value equals to 1. Or in symbols, we denote that 0 factorial, which is equal to 1. So here is the explanation behind why is it the factorial of 0, which is equal to 1. For the values of n, or natural number, which is equal to 0, the definition of n factorial as a product which involves the product of no numbers at all. And so it is an example of the broader convention of an empty product. A product of no factors, it is equal to multiplicative identity, so which is 1. So meaning to say, when you use the value of n which is equal to 0, so the definition of 0 factorial which involves the product of no numbers, meaning to say some of their factors are nothing, so it cannot be appeared with these numbers. We cannot express as a product, but it is nothing. So it is an example of the broader convention, which is the empty product. So if the product is empty, meaning to say the product of no factors, which is equal to multiplicative identity. So we use multiplicative identity of multiplication, which is 1. So for example, we have 3 times 1 equals 3, 2 times 2 is equal to 2 times 1 equals 2, 5 times 1 is also equal to 5. It is what we call the multiplicative identity, where the identity element which is equal to 1. So that's the reason why any of these numbers that could be used, or it could be disappeared, meaning to say the product is nothing or empty product, so which is equivalent to the multiplicative identity. So let's continue from the factorial values from 0 to 10. So we all know that the 0 factorial, which is equal to 1, and that is our special case. Next is 1 factorial is equal to 1. The next one is 2 factorial is equal to 2 times 1, so which is expressed using the factorial notation. So 2 times 1, so we get 2. We have 3 factorial, so we all know that the series of these natural numbers lower than going to 1, from the larger number going to 1. So 3 times 2 times 1, so we get 6. So 3 times 2 equals 6 times 1 equals 6. Okay, next, 4 factorial is equal to 4 times 3 times 2 times 1. So 4 times 3 equals 12 times 2 equals 24 times 1, which is 24. We have 5 factorial, so 5 times 4 times 3 times 2 times 1, so 24 times 5, so we get 120. The next one is 6 factorial, so we all know that the value of 5 factorial is 120, so multiplied by 6, so which is 720. 7 factorial, which is 5040. 8 factorial, which is 40,320. 9 factorial, which is 362,880. And 10 factorial, so we express as 10 times 9 times 8 until 1, so which is 3,628,800. So these are the factorial values from 0 to 10. So my dear friends, students, and viewers, can you memorize all of these factorial numbers from 0 to 10. So can you do that? So this is challenge for you that is easier to memorize and know the values of its own factorial values, or the factorial of the given natural number from 1 to 10. Let us proceed to, okay, so we have the derivation of this formula. We all know that the given natural number, which is represented by color green, so which is started by their own number. So 1 of course is 1, 2 is also 2, 3 it becomes 3. So the given natural number begins with a natural number itself. Okay, we derived this formula. We have n factorial. So n factorial, which is equal to, copy the value of n. Next one is all of this color blue, which has a difference between the two numbers from the green ones to the blue ones. So the difference between 2 and 1, which is a gap of 1. Also 3, it becomes 2, 4, it becomes 3, 5, it becomes 4. So in short, we have derived that the natural number which is subtracted by 1, that is our next factor. Next is, we have the violet ones, which subtracted from the natural number by 2, and then and so on until you continues to 3 times 2 times 1. That is all the last 3 factors, which is indicated by color red. So we have the formula. For factorial notation, we have n factorial is equal to n times n minus 1 times n minus 2 until reaches to 3 times 2 times 1. Okay? Or in some other ways, you cannot use the 1 as the factor, because if the answer, can you arrive from n going to 2, so the answer is still the same. Okay? So there are some ways that you cannot omit the number 1 is the last factor in the given factorial. Okay? So again, the factorial function of the positive integer n is defined by the given product. So this is the formula for factorial notation. So n multiplied by n minus 1, n minus 2, until reaches to 3 times 2 times 1, or until 3 times 2. So where n is any natural number. Okay, my dear friends and students, so let us discuss some of their factorial numbers which is higher than 10. So 11 to 20, okay, which is at extremely large numbers. So we have the columns of the value of natural numbers, and it's the factorial values and factorial. So the factorial of 11 is 39,916,800. 12 factorial, which is 479,001,600. 13 factorial, we have 6,227,020,800. 14 factorial, which is 87,178,291,200. And of course, 15 factorial, which we have reached already in a trillions place. Okay, so we have 16, 17, 18 factorial has reached a quadrillion. 19 factorial, 20 factorial, which reaches the quadrillions place value. Okay, so we have the factorial values which is higher than 20, so which is expressed in scientific notation. So we have expressed of this answer of the given factorial with extremely very large numbers. So the value of 25 factorial, which you all know that 1.5 something multiplied by 10 to the 25th power. We all know that the factorial of a million, which is 8.263931688 times 10 raised to the power of 5,565,708 power. And we all know that 10 raised to the power of 100 is known as the Google number. We all know that this number, which is expressed by 1 followed by 100 zeros. And we all know that the value of this, the factorial of a Google, that is 10 to the 10th power to the 101, 908, 307, 309, 775, 4820 exponent. So these are the factorial values which is higher than 20, from 20 going to the value of the Google. Okay, so hereby some of these examples on how will you going to simplify using the fundamental operations which involving factorials. So, hereby representing some of their illustrative examples on how will you perform fundamental operations using the Pemdas rule by involving factorials. So let us begin with our first example. So before that, you will be going to use factorial notation to perform the fundamental operations, and you will be going to simplify. So let us begin with our first illustrative example. How will you simplify 3 factorial plus 4 factorial plus 5 factorial? So to simplify this mathematical expression, here is the solution. So first, we will have this our given, and that you will be going to put the given first. So we will be going to express the given factorial to its factor form. So we all know that 3 factorial, let's start with a factor of 3. So 3 times 2 times 1. And then the second term we have 4 factorial. So which is start by 4 times 3 times 2 times 1. And we have the next term which is 5 factorial. So the expanded form into 5 times 4 times 3 times 2 times 1. Okay, the next step to do is to simplify this factorial. So it could be used factors. So 3 times 2 times 1 is also 6. 4 times 3 times 2 times 1, you have 24. And 5 times 4 times 3 times 2 times 1, which is 120. Okay? So in easier use, it also you can memorize some of their factorial factors by its respective the factorial of the given natural number. So we all know that 3 factorial is 6, 4 factorial is 24, and 5 factorial which is 120. The next step to do is to combine similar terms, which all these are constants. So 6 plus 24, so we have 30, 100 by 120, so which is 150, and that is the final answer. So let's move on to the second illustrative example. Illustrative example number 2. So you will be going to simplify 7 factorial minus 6 factorial times 3 factorial. Okay? So to simplify the given mathematical expressions that containing factorials, so here is the solution. So to start, we will be going to simplify this mathematical expression with the factorials. So we all know that the 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2. Okay, so in this process, this factor, you cannot omit 1 as the last factor. So we all know that when you multiply by 1, the answer is still the same. So until we just go to the last factor, which is 2. Then minus, so expand 6 factorial, we have 6 times 5 times 4 times 3 times 2. And 3 factorial, which is 3 times 2. Okay, if needed, you will be going to direct the factorial value. So we all know that 7 factorial is 5040, 6 factorial, which is 720, and 3 factorial, which is 6. Okay, the next step to do is to apply multiplication based on Pemdas rule. So 720 times 6, so we have 4320. And then we get the difference between two numbers, 5040 minus 4320. So we get a difference of 720. And that is our final answer. So my dear friends, students, and viewers, let's move on to the next illustrative example. How about you will be going to simplify the quantity of 4 factorial squared plus the quantity of 2 factorial raised to the power of 3 minus 5 factorial 3 factorial. So my dear friends, students, and viewers, to solve this mathematical expression, here is the solution. So to simplify, we will be going to simplify this mathematical expression that containing factorials. So let us apply first the Pemdas rule. So let us begin with the inside the parentheses. So we will go into simplify for factorial inside the parentheses of the first term. So we all know that 4 factorial, which is 4 times 3 times 2, through factorial, which is 2 times 1 or 2, and 5 factorial is 5 times 4 times 3 times 2, and 3 factorial, which is 3 times 2. And then we'll be going to simplify simultaneously their product. So 4 factorial, we all know that 24 squared plus 2 factorial cube. 2 cube, which is 8 cube. Next is 5, 4, 3, 2, the product which is 120, and 3 and 2 which is 6. The next step to do is to simplify the first term which is 24 squared. So 24 squared which is equal to 576 plus we get the perfect cube of 8, so 8 cube which is 8 times 8 times 8, so which is 512. And then we get the product of these two numbers 120 and 6 which is 720. Okay, the next step to do is to simplify all of this addition and subtraction from left to right. So 576 plus 512, so we get 1088. Then subtracted by 720, so we get the difference which is 368, and that is our final answer. So my dear friends, students and viewers, let's move on to the next illustrative example number 4. How will you simplify the given mathematical expression, the quantity of 3 plus 7 all over factorial, all over the quantity of 4 factorial minus 3 factorial times 2 factorial all over factorial? So my dear friends, students, and viewers, to simplify this mathematical expression that express into quotients with containing factorials, so here is the solution. So will you going to simplify this kind of mathematical expression expressed as the quotient that containing factorials? So copy the given first, and then you will be going to perform using the Pemdas Rule. So let us begin first with parentheses. So you will be going to perform first the inside parentheses by adding the numerator part. So 3 plus 7, so we get 10. Then copy the factorial symbol. All over, you will be going to express this factorial values simultaneously. So we get 4 factorial, which is 24, minus, we all know that 3 factorial, which is equal to 6, and 2 factorial, which is 2. And then you will be going to simplify 10 factorial, so copy. Then 24 minus 6 times 2, so 6 times 2, which is equal to 12. And then 24 minus 12, which is 12. The next step to do is you will be going to expand each of these factorials. But in order to ask to cancel or to simplify the quotient, so you will be going to expand one number which is the greater. So we all know that the smallest number with the containing factorials, which is 10 factorial, so just leave it. And you will be going to expand the larger factorial values, which is 12. So we express that from 12 times 11 until reaches to 10 factorial. Okay, so why is it the last factor is 10 factorial? So we all know that 10 factorial, which continues expand from 10 going to 1. So in order to us to cancel the 10 factorial. So cancel 10 factorial, both of the numerator and denominator. So which is remaining is 1. So 1 all over, except from 10 factorial, we have 12 times 11. And simplify the denominator, so which is 12 times 11, we get 132. So the final answer is 1 all over 132. So my dear friends, students, and viewers, so let's move on to our last illustrative example. Okay, so this kind of mathematical expression is complicated to match. So you will be going to simplify. So 2 factorial times 7 factorial all over 6 factorial plus the quantity of 5 factorial times 3 factorial all over 4 factorial quantity squared. So to express this, or going to simplify that kind of mathematical expression that containing radicals, here is the solution. So to solve this, so you will be going to simplify that kind of mathematical expression that is complicated. So let us begin first to simplify each of these factorial values simultaneously. So the first step to do is it's either you'll be going to expand it all together, or you will be going to cancel out. So we found out that 2 factorial is 2, 7 factorial is 7 going to 2, and 6 factorial from 6 going to 2. So we cancel 6, 5, 4, 3, 2. Both of the numerator and the denominator of the first term. Okay, same manner with 5 factorial. So 5 factorial, 4, 3, 2. 3 factorial, we have 3, 2. And 4 factorial, we have 4, 3, 2. And we cancel 4, 3, 2, both the numerator and the denominator of the second term. So we have the remaining factors. So the first term, which is 2 times 7, and for the second term, we have the quantity of 5 times 3 times 2 squared. So 5, 3, and 2. Next, simplify each term simultaneously. So we have 2 times 7, which is 14, plus 5 times 3 times 2, quantity squared. So we have 30 squared. So we get the value of 30 squared, which is 900. So 30 times 30, and then 14 plus 900. So we get 914. And that is our final answer. So my dear friends, students, and viewers, now you learned on how we'll be going to simplify mathematical expressions that containing factorials. So that's the end of our video. Thank you for watching. So please like, share, and subscribe, and hit the notification bell to my video channel, Sir Palmath TV. So thank you very much for watching. See you on next video. God bless us all.